Okay, in this example we're going to compare two population proportion. So we're not comparing means anymore, we're comparing population proportions. So here's an example, and I'll show you how to work this one out using the calculator. A jar containing 130 mosquitoes was sprayed with an insecticide of brand A. So a jar that has 130 mosquitoes was sprayed with brand A insecticide. And it was found that 98 of them were killed. When another jar with 150 mosquitoes of the same type was sprayed with brand B, insecticide, it was found that 120 mosquitoes were killed. All right. The question: do the two brands differ in their effectiveness? U is alpha equal 5%. So we want to know whether the two brands have different effects on killing mosquitoes. Okay, this is a test of proportion, guys. So we have two population. Population 1, which we use the brand A on this population, and we have population 2, which we use the brand B. We're going to refer to the population proportion as P1 and P2. Okay, here's what the question is about. He says, if you read the question, do the two brands differ? So that means, are they different? That's the question, that's the claim. So your claim is P1 is different from P2. And you just put claim here. And the null hypothesis will be the complement sign, which is the equal sign. Okay, guys, now we're going to go to your calculator. You're going to use, it's very simple now. You go to stat, tests, and you go to two proportion z-test, two prop z-test. So stat, tests, two prop z-test. Okay, x1, you enter the value of x1. x1 is the number of successes from brand A. So x1 is given in this problem to be 98. x1 is always less than n1. n1, it's the total number of mosquitoes from the first sample, which is 130. x2, you enter the value of x2. x2 is going to give you what is x2? He says 120, and n2 is 150, and now P1, you have to choose the alternative. It's always the last one before calculate the alternative hypothesis. It's different from, make sure to select that one, and then you hit calculate. After you hit calculate, guys, you're gonna get Z, which is the test statistic. It's negative 0.93. We need 2 digits for Z and 3 digits for T. And the p-value, that's step number 3. The p-value here is, you're gonna see 0.35. Okay, you're making a decision now. Is the p-value more than alpha or less than alpha? Well, it is more than alpha in this case. P-value, which is 0.3536, is more than alpha, which is only 0.05. So what's your decision? The decision is fail to reject HO. You cannot reject HO, and the claim is in HO. Every time you use the word fail, then your conclusion has to have, there is not enough evidence. So there is not enough evidence at the 5% level of significance to support the claim that the 2 brands differ in their effectiveness. So that is the conclusion of this problem. So in this section, guys, when you are testing the proportion, you have always 3 choices for the hypothesis, for HO, HA. You always have to choose one of them. I'm just going to write them down for you. HO, HA. You either will have this situation. That's one choice. Or you could have this. Or you can have that. Last one. P1 is less than or equal to P2, and P1 is greater than P2. Some books, if you go online, for the null hypothesis, whatever the sign, whether it is equal, greater than or equal, or less than or equal, they use an equal sign, which is okay. But the alternative must have either different from, less than, or greater than. Now, how do you know where the claim is? Is it in HO or HO? It depends, on the wording of the problem. If he says test if the 2 proportions, for example, are equal, means P1 equals P2, then you know the claim is in HO. But if he says test that the 2 proportions are different, then you know the claim is in HA. I hope that helps.